Algebra 2. In the last unit, we learned how to solve quadratic equations. Quadratic equations, remember, is an equation that has basically a power of 2. We learned how to solve by factoring, solve by square roots, quadratic formula, and completing the square. In this little mini unit, we're just going to look at the relationship of what we just finished, like solving quadratics, to how we can look at it graphically, the graphic approach. And this is just going to be like a one-day little lesson. Basically, what you need to know about the graph is that the form needs to be in the same order, standard form. Ax squared, there's the quadratic term, the bx is the linear term, and the c is the constant. It needs to be set equal to 0 as well. The graphs of these quadratic functions or equations are called parabolas. P-A-R-A-B-O-L-A-S. Parabola. Please do not pronounce it a parabola. I have heard that before, but it's a parabola. These are U-shaped graphs. Sometimes the U's turn upward, and sometimes they actually flip upside down. It really depends on the coefficient, basically, of the x squared term. So, for example, when the a is positive, like a 2x squared, a 7x squared, then the parabola is going to open upward. When this number, the a, is negative, it's going to automatically flip the parabola upside down. Parabola has a vertex, which is the starting point, that is the highest or lowest point on the graph. The vertex of the parabola, again, is the highest or lowest point on the graph. That depends on the shape of the parabola. If the parabola is opening upward, then the vertex will be at the bottom of the graph, meaning it's the lowest point. If the parabola is opening upside down, the vertex is the highest point on the graph. An axis of symmetry is an imaginary line that divides the graph in half. And so that line we usually use like a dash line to illustrate that. X-intercepts, which are points or places where the graph crosses the x-axis, there are other names for this, and so I'm going to go ahead and highlight all of these. X-intercept, a root, a zero, a solution. All four of those words mean the same thing. And so with a graph, it's easy to tell where this graph to the side crosses the x-axis. It's the points I've highlighted. Tying it back to what you've just finished learning on how to solve quadratic equations, you learned 4 different methods. Well, the solutions to those questions can be found graphically by just looking for the x-intercept. So in other words, when you're looking at this picture, you can see that this graph crosses at 2, 0 and negative 2, 0. The solutions are 2 and negative 2. So if I had given you the original equation to this picture, you could have solved that quadratic equation and gotten those 2 answers. So anytime you get a solution to a quadratic equation, basically what that means in a graph is it will be the place or places where the parabola crosses the x-axis. So again, that's called x-intercept, roots, zeros, solutions. It has 4 different words, but it all means the same thing. In this particular picture, the vertex, which is the highest point, since this parabola is turned upside down, would be this location here. So the vertex for this picture would be the location 0, 3. 0, 3. The solutions, x-intercepts, roots, would be the places I've highlighted. Those are the x-intercepts, roots, solutions, or zeros. The locations of these on this graph are 2, 0, and also negative 2, 0. 2, 0, and negative 2, 0. The axis of symmetry is an imaginary line that divides the graph in half. That imaginary line in this case, in all cases I should say, will always go through the vertex. So if the vertex is at 0, 3, then your axis of symmetry is going to be that vertical line going straight through it. What we normally do is just kind of, like I said, draw a dashed line. It's not necessarily part of the original graph. It's just an imaginary line that you kind of visualize, and you should be able to tell based on the direction and also based on the distance where the middle of that parabola is. And so in this equation or this graph, then the axis of symmetry, and I'm going to abbreviate that AOS, axis of symmetry, is going to be this vertical line. Since it's a line, it needs an equation. So the equation of a vertical line has everything to do with all these points. And so all these points on this line have something in common, like this one 0, 0, 0, 1, 0, 2, 0, 5, and so forth. Okay, so instead of writing all those down, change my mind, instead of writing all those points down, I'm just going to give you the actual equation for that. So if all the x's are 0, then the equation for that axis of symmetry would be x equals 0. So in this picture, again, the vertex is the highest point in the graph, so it would be 0, 3. The x-intercepts, roots, zeros, or solutions are the places where your graph crosses the x-axis. In this picture, it's 2, 0 and negative 2, 0. And the axis of symmetry, which is the imaginary line that goes through the middle of the graph, can be explained or described by the equation x equals 0. Alright, so that's just like a little, like I said, a mini lesson on different parts of a parabola that you need to know. Vertex, x-intercepts, and axis of symmetry. So what we're going to do right now is the similar things. We're going to determine the vertex, the AOS, and the x-intercepts of the following. If you'll take a look at number 1, we can see that it's a U-shaped graph. It is a parabola. The vertex is actually a low point on the graph. It's the place where the graph changes direction. Okay, the vertex. Sometimes we'll call it the starting point. But the vertex for number 1 that I've highlighted in purple, you'll have to give the answer in ordered pair form, would be 1, 2, 3, 4. Negative 4, 0 is the vertex of this picture. Secondly, you need to give me an AOS. Axis of symmetry, remember, is the imaginary line that's going through the middle. Because it's always going to be a vertical line with the parabolas we're going to look at, your answer form will always be in the form of an equation. X equals something. And that value depends on where your axis is. And so when I take a look at my vertex, I find it, then I know where the middle is. And that axis again goes through the halfway through the, or goes through the middle, and it should be the same distance from like any random point on this graph. Like the distance from this point to the axis is the same as the distance from this point to the axis, or it should be. I think my graph's a little bit off, but that's supposed to happen. This distance is the same as this distance. Okay, so how do I describe that? Well, the vertex is negative 4, 0. The axis of symmetry is the equation x equals negative 4. And then third, find the x-intercepts or the solutions. Again, solutions, tying it back to what we just finished in the last unit. What's the actual answers to this quadratic equation? Well, if I don't have the equation to solve using factoring or formula or whatever method, then and I have a graph, all I have to do is find the x-intercept. That location is negative 4, 0, and so that would be the answer, negative 4. You can write it like this if you want an ordered pair, or you can just say x equals negative 4. It's a solution. Question 2. Look at that parabola. Again, notice that this parabola is opening upward. That means the a in front, the coefficient of x squared is positive, remember. Vertex is the high or low point on the graph. If the parabola is opening upward, then the vertex is going to be the low point. and it's going to be, looks like right there. Your job is to find that location, so we're going to count back one, looks like 1.5, down 1, 2, 3, 4, 5, and we'll say 5.5. So the vertex is negative 1.5, comma, negative 5.5. Next, we need to know what the axis of symmetry is. Again, that's the imaginary line going through the middle. Since it's a line, we describe it as an equation. The axis of symmetry would be the line that's going through the vertex, because the vertex is always in the middle. And so describe that equation. Well, it crosses the x-axis at negative 1.5, so that would be how we would write the answer to that. X equals negative 1.5. Alright, last, we need to know where the x-intercepts are, because that's the same thing as solution of the quadratic. And so we're going to focus on places where this graph crosses the x-axis. Okay, so we can do that by coming back in here. Let's see, this one's at 2, 0. And this location, 1, 2, 3, 4, 5, is at negative 5, 0. Now let's continue with the third one. Notice that the third example is a parabola that actually is turning upside down. And so the vertex is going to be a high point on this graph. And that's going to be this location here. I've highlighted in red, and then you'll just have to give me the exact location or ordered pair. 1, 2, 3, 4, 5, 6, and down 2. So 6 and negative 2 is the vertex of that parabola. The axis of symmetry is a line in the form x equals something. Here is the middle of that parabola. Imagine that dashed line drawn in. The equation for that is 1, 2, 3, 4, 5, 6. X equals 6. Last are the x-intercepts or solutions to that problem. Where does this graph cross the x-axis? Where does the graph cross the x-axis? Well, here's the x-axis. This parabola is not crossing it, nor will it ever, because this parabola is decreasing and moving downhill. So sometimes what happens is, especially in this, like a graph like of this nature, if it's not crossing the x-axis, then you have to say no answer or none. What does that mean? Tying it back to the last unit, that means if I gave you the equation to this and asked you to solve it, you would not be able to find the answer. And so that means, tying it back to quadratic formula, that the solutions are imaginary. These solutions are imaginary. So kind of keep that in mind as I kind of moving forward. Recall that in the quadratic formula section that I went over discriminant with you, and I told you that when the discriminant is 0, there is only one x-intercept. Well, this is what happens when in the formula, if the discriminant is 0 and you can only give me one solution, like x equals negative 4, that means the graph is only going to hit the x-axis in one place. When the discriminant is positive in the quadratic formula, then that indicated that there were two real answers. What that means in a graphing situation is that there's two x-intercepts. These are the solutions to the problem and also the places where the graph crosses the x-axis. Thirdly is what happens when the discriminant is negative. Now, we didn't practice, I shared that with you, but we didn't have practice problems like that because we haven't learned how to do imaginary numbers yet. But I wanted to go ahead and share with you the graph. So if you can't give me a real number answer, What that indicates in a graphing situation is that your parabola will never cross the x-axis. And so I want to make sure that you're taking good notes, you're writing things down that you're hearing me say too, not just what's on the board. So I'm going to repeat that. Very important, because a lot of times they'll ask questions similar to this on ACT. It's good to remember. So when you're dealing with a quadratic equation, x squared, just remember you can have either two answers, two real answers, one real answer, or no real answers, which means imaginary. If it's two real answers, then your graph will look like example 2. It will cross the x-axis twice. Two real answers will cross the x-axis twice. If your problem gave you only one solution, like one number, then that is indicated with this graph. It's only going to cross the x-axis one time. And then lastly, if your discriminant is negative and you won't be able to give me a real number answer, then that means your graph will never cross the x-axis. Okay, so parabolas, U-shaped graphs, vertex or vertices is plural for that word, axis of symmetry, x-intercepts, and all these words I need you to kind of have in your head going forward so you understand the language I'm using.